That would help if I had some volume, wouldn't it? Sorry about that. Today we're going to model up a tapered gib for a Sidney lathe. I become friends on Instagram with Kenny Lee. He has a 1942 14-inch model that he's restoring, and his is broken. So I went back out to the shop and took mine out, and I, would happily to model it. Or he wanted dimensions for it, and I said, well, I'll just model it for you. And I asked him if he used any CAD packages or what he used, and he uses Fusion 360. And I said I do too. So that even works out even better, because Fusion 360 is all cloud-based, and users can share the files between them. You can also share a public link where people can look at it and stuff like that, but I don't believe they can edit it. So what I'm going to do is model this thing up. I'm going to show you some pictures of what he has. Let me get my center monitor up here. All right. And this is his lathe when he was picking it up. And this is Kenny here. But he's remodeling his, and he asked, he's cleaning all his. He's using simple green. But his stuff, he said, was very, very, very tight. And in the process, the gib was broke, or it got broke. I couldn't remember what he said. So he asked me to model it, and I said, or give him the measurements. I said, sure, well, I'll just model it. So he's coming along quite nicely on his. He's getting it polished up and getting ready for paint. So this is part of the taper attachment here on the handle for the cross slide, and this is the thread dial indicator. Mine's missing this, so I'm going to either have to source one or I'm going to have to build one. So, but let's get on to Fusion. So, this is the way Fusion looks up when you first bring it up. And what I'm going to do is I'm going to go and start a new project, or create a folder in my projects, I should say. And I'm going to call it Kenny. So now I'm going to open up that folder, and we're going to save a drawing, and we're going to call this Tapered Gib. We're going to start from the very beginning to make it easy. So it'll show in here in the side when it's ready to go. But let's go back over here. Back to this shot here. What we're going to do is it's pretty simple to draw. It's tapered, though, is the only confusing thing about how to do it. But there's a command in Fusion called Loft, and it allows you to create an object between two different points. You can do a square on one end and a circle on the other, and it'll make it go to it. But this we're going to do, this side is obviously bigger than this end here. But the easiest thing to do is we're going to draw this end profile here, and then we're going to create an offset plane so we can draw this profile on it. And then we're going to connect the two with a loft command. It's pretty simple to do. And then we're going to put this slot in it. Mine is broke off. The way the bolt head's made, it fits in this 3/16 inch slot, and the back side of mine's broken. So I reckon when you could loosen the gib if you wanted to, but you can reach in and tap it on this end if you need it loose. But I don't know any gib that's ever going to loosen up. It's almost always you got to tighten it. So we'll do that, and then on this end, it has another taper, a 1/4 inch on this side, and on the opposite side it's 1/2 inch. So what we're going to have to do on this plane is to draw that angle on this front plane, and then we're going to have to construct another plane back here somewhere so we can draw this other back angle on it. So it's pretty simple. So what I did is I went out to the shop earlier today, and I made a little drawing, and it's mostly of the two ends and then the total length of it. So let's get started. It shouldn't take that long to do this. Hopefully this video won't be too long. So we're going to sketch. Let's see, what do we want to do? Let's turn it to the front. We're going to start on the front pane. We're going to draw a line. We're going to create that little notch cutout first. Let me see. Let's do this right here. We're going to create this little notch cutout right here first. So let's do over this way, 0.185. I'll zoom in a little bit so we can see it a little better. And then we need to go down 0.185. And then we need to go over from this point. It's 750, 0.750 minus 0.185. So the easiest thing to do is just 0.750 minus 0.185. There you go. And then this, we need a line from this height up here. This is straight up. And of course, when you hit the button to finish drawing your line, you need to dimension it. So I'm going to dimension it's 0.3705 minus 0.185, which is that notch. And then the angle, there's an angled line that goes right here. That's a 60-degree angle. And what I did was I went out to the went to my chop saw, and I cut, 30-degree angle, 29-degree angle, 20. I was trying to figure out, I have the measurements, and I was fairly certain it was 60 degrees. So I said, well, the easiest way for me to double check it, I don't have the fine measuring instruments that, some machine shops have, was I just cut a block of wood and lined it up. I've been, woodworking for years, so, that's the easiest thing for me to do. So we're just going to draw a line from here up at some angle. Doesn't really matter. And then I'm going to dimension that line. You hit D, and up here, and it's 60 degrees. So there it is. And then I need another line that just goes from here at a 90 degrees that away. So we're going to trim the excess. I reckon you could have dimensioned it and did it that way too. That's just the way I do it. So now we're going to finish dimensioning this stuff so we can lock this stuff all in. So what else is here? Trying to figure out what else needs to be dimensioned. This here needs to be dimensioned. And that should do it. Alright, so that's the end of that sketch. That's the fat end. That's the fat end of this tapered gib. I want to keep on saying jig. Tapered gib. So that's the fat end of it. We can flip it around, and now we need to do this same thing. But we don't have a place to draw it on. So we have to create another plane to draw on. So the way you do that is you create an offset plane. So I'm going to stop this sketch, and you can see the, whoops, let me get the thing so you can see it again. I stopped the sketch, and here's the profile of the tapered gib. So what I'm going to do, I'm going to turn it just a little bit so you can see. And what we're going to do is we're going to create, up here you construct an offset plane. So it's asking you what plane do you want to do, and I want to do that plane, and I need to move it back. Well, how far do you need to move it back? The length of the gib, which is 9.375. So 9.375. So now, if I zoom out, there's my plane. So there it is. So I'm going to, up here at the front corner, I'm going to go to the back. And you can see, we're looking through that plane we just constructed to what we have in the front. So now we need to draw that same thing. And the easiest way to do it, I'm just going to trace some of this stuff, and then we'll do the rest of it. So I'm going to create a sketch on this new plane, and I'm going to draw a line from here to here. I'm going to repeat the line from here to here. Repeat another line from here to here. I'm going to repeat a line from here to somewhere in here. And then another one from here to somewhere over there. So now we need to dimension this. This top one, over dimension. I should have known better to do that. So let's delete that. Oh, not D. I keep on hitting the D for delete key, and that's not the way to do it. So, so let's draw this line from here this way, 0.375. All right, there's that top part. Now I need to draw the angled line, and it doesn't matter. I'm just going to draw one right like that. It doesn't matter, but it has to be parallel to this one. So you can put a constraint. This bottom part here is a constraint. So click here, click here. Oh, I hate it when I do that. It happens every time, and I know better, and I keep on doing it. So let's back up. Where did this king come from? Delete. All right, now an angled line from this point down here, and that parallel here, here. Really? It never fails. It never fails. Every time I want to do this, it works so good. So let's delete this. All right, now, will it let me do it now? Nope. Parallel, here to here. Thank you. Now let's draw a line from here this way, 0.375, and we'll put a coincident between this point and this point. There we go. That'll work too. Now we're going to trim these other ends. Now when I did it earlier today, everything works great. So, you know, what do you do? So now we have the two parts drawn. This is the front half, the big half, and this is the little part. Now we're going to use a command called loft. So we create a loft, and it asks you to prick the two profiles, and there you go. Tapered gib. For the most part, you know, it works. It you know, does pretty good, and we're going to, you know, check some stuff here. I want to see, just for reference, you know, how long some of these are. 9/16. Yep, that is. And we'll check this little end down here, which should be 375, which it is. And that should do it. So now we got most of it done already. And what's it been? 10 minutes, if that, including my mistakes. So it's looking pretty, you know, it looks like the gib does. You know, if I can get it centered up here, roll it over a little bit. There's that gib, and here's that gib. Looking at it just like that. Whoops, get it up here in the camera. Looking just like that. So now what we need to do is we're going to mill this slot. We're going to put this slot in the drawing. So we're going to, on the front face here, on this face right here, we're going to just draw a little rectangle, and then we'll just cut the material away. Excuse me. So what I normally do is I'll just grab a 2-point rectangle, and I'm going to draw on this, well, not that plane. Back up. Stop sketch. Let's get back to where I need to be. Right here on this plane. And I'm just going to draw a rectangle. Doesn't matter what the size is. So now we have the size. Now I'm going to dimension it. And from the measurements that I got from this point here, so I'm going to hit D for dimension, from this point here to here is 1/2 inch, so 0.5. And then the measurement, the depth of it right here was a 1/16, 0.0625. So there's that. And then the width of it is 3/16. But I'm going to use something different. I don't know if all these bolts are made the same. So I'm going to use a parameter, and it's just a user parameter that I can put in here, and it'll allow just easy changes to that without doing much of anything else. So I'm going to add a parameter, and I'm going to call it compound gib bolt head or something like that. It doesn't matter, you know. And it was 3/16 of an inch. It was what, 0.1? Oh shoot, just do 3/16. 3/16 of an inch, 0.1875. So do that, and whatever I change, if I need to change that, or if Kenny needs to change it, say his is a quarter, he doesn't have to change the drawing. He just needs, well, I'll show you. Let's just say okay here. So let's dimension this slot. So I'm going to hit D for dimension right here, and whatever I call that thing, I'm going to call it this compound gib bolt head, this user parameter. So hit enter. So there it is. That's all there is to it. So now we've got the rectangle drawn that we need to cut the slot into it. So I'm going to stop the sketch. I'm going to hit Q on the keyboard for press pull, and I'm going to cut that material out. So just drag it through, and it's asking for a cut operation. You can do a join or intersect, but we want to cut it out. So you hit OK, and you're done. Now back to this parameter. See if I change this to, let's just say, a quarter, or not quarter, let's make it more dramatic, 3/8 of an inch. You see, it just automatically changes that. So if his bolt head is a quarter, all he has to do is come over here and put in a quarter. Now it's dimensioned that to the size of his bolt head. So mine was 3/16. So that's why I put 3/16 in there. And you don't have to use all decimals. You can do 3 divided by 16. It knows, it's very intuitive on what you're going to do. So I'll leave that in there like that. So that's that. Now we have the slot that's cut in here. Mine, missing the back part of it, but mine works fine like it is. It's never going to back out, and it can only go in so tight. So, maybe one day I'll build one when I have more machinery and can grind one, but it's a piece of cast iron that's, that I don't have. So this one works, so we're going to do that. So now we need to cut this taper on the end here. So we'll do that on the other end. So let me go back to the drawing here. Alright. So starting from this same end, right down, I'll zoom out, come down here where we can see. I'm going to rotate this up a little bit because I'm going to do the drawing on this back plane right here. It's 1/4 inch from here to here. So all I need to do is sketch a line on this plane from here down. It doesn't matter. I say it doesn't matter. Every time I said that, it doesn't work. So let's dimension it from here to here. Really. D for dimension. Oh, there's not a line to intersect it. Duh. So let's draw another line first. From here to here. And another line from here, 1/4 of an inch. And we'll just make that coincident to there. That's the easiest, we can do. Oh, let's see. Can we not do that? I think we can. Yeah, that did it. So used a constraint. It blocked it all in. It's all black, so it's not going to move anymore. So that is that profile. Now we need to make the profile on the other side. But I have a problem. There's not a plane here. Let me zoom back out. I'm going to stop that sketch so we can see. So I need a plane here that I can draw another triangle, but a 1/2 inch to create that loft through there. So what I'll do is we're going to construct another offset plane. From here, we're going to go this way. I'm not exactly sure where it's at. Measurement wise, it was 0.560, so we can do 0.560. I think that's what it was. Pretty close. So we hit OK. Now we need to draw on this plane. So I hit line. We're going to draw on this plane, and we'll do the same thing from here to here, the line, and then from here this way. But it's 1/2 an inch here on this end, so it's 0.50 here. And then we need to draw another line from here to here. So that's created that back part, that other line. So I'm going to stop the sketch. Now we have what we need to do to create that weird looking taper. So we're going to do another loft from this point to this point and hit OK. And there you go. There is that weird looking taper. Let me go back to this other one so you can see it. No, let me blow it up full screen here. You see how that taper is. So it's 1/2 an inch on this end. From here to here is 1/2 an inch. But on this side, it's only 1/4 of an inch. And that's what we just did there. So now, that's got all the taper jig done. That's all there is to it. So now what I can do is I'm going to go ahead and save it, and then we can go over here and I can right click and I can either share a link. We can start a live review with Kenny if he was online watching. But what I'm probably just going to do is I'm going to just add him to the whole project. So I will enter his address, and then he'll get an email saying that his project is ready to go. So, of course, I didn't switch it. Let's go back. All right, here we go. This is what you do when you're doing it live. So what I do is I'll save the tapered gib, and then I can go back down into my projects where his is saved at, right here, and I can right click, and I can share the public link with them. If you just click it, which it doesn't matter, a public link will come up, and eventually, and then you just copy and paste that and email it to who you need to email it. Or what I can do is I'll just share this whole file with Kenny, and he can do any modifications or any what he needs to do. If this slot down here at the bottom is not the right size, he can change that using the parameter that we had set for the compound gib bolt head width, which is a long thing, but it doesn't matter. You can put anything you want in here. When I build cabinets, I put the parameters in here of plywood thickness, because plywood comes in all different thicknesses. So all I have to do is change that, draw my set of cabinets, change the thickness of the plywood, and everything automatically changes. And then you just, good to go. So that's how you do that. And I wanted to try. I've got a pretty smoking computer, but I keep on saying AutoCAD. In Fusion 360, you can render this, so it knows that this is a piece of steel because of parameters that I set up earlier. And of course, I don't know if I can do it with my streaming software. Well, we're going to try it. So if we crash, we crash. So we'll go to the render environment, and heck, I'll just hit the button. What the heck? If we go away, we go away. My streaming software uses the GPU to do most of the streaming, and Autodesk Fusion Fusion 360 uses the same render engine to render it. So let me spin this around here so we get a better view. It's still a pretty good computer, so let's change some settings. Not that one. Scene setup. This is pretty neat. Alright, we'll just close and we'll let that run for a minute. If you have any questions, feel free to ask. It is a little slower running my streaming software. I am using, just maxed out my CPU, so if we crash, we're going to crash hard. Hopefully it's doing pretty good. I better stop this in case it crashes. So it didn't like that at all. Now I have a 6700 processor, so let's go back to the model environment. Yeah, maybe it'll live better here. Here we go, back down to 52. So, and that's all we're going to do today is model a tapered gib. And that's one good thing about I'll tell you what about the machining community. Any other place on YouTube or Instagram and all that, everybody gets butt hurt and stuff on asking questions on all that. The machining community is completely different. You can ask almost anybody. If you have a question on how to do something, you can ask one of the big name guys. I'm sure if you ask John Saunders at NYC and CNC a question about Fusion, he'd be happy to tell you. Or if you have a manual machining question, Adam Booth or Keith Fenner, and I feel almost positive they'll do it. A Maker, if you do Duresta, Tom Zelikman, who a couple hours to the east of me, they help each other out and help me out, not just through their videos, just knowing them too. They're nice guys. If you ever have a chance to get to what's coming up? I reckon John Saunders' open house is coming up. I don't think he's having it this year. I think he's having a meetup in Chicago during IMTS. But if you can get together with those group of guys just to talk to them, they are the nicest bunch of guys. I haven't met Keith Rucker. I've met Tom and Adam Booth and John and Grimsmo. Jimmy Duresta is a cool dude. Mr. Pete, all these guys, man, they're just nice guys. Always wanting to help. So You know, if you ever have a question about machining or anything like that, or have a question about your tools, I mean, throw a picture on Instagram and tag somebody in it. Maybe they can help you. This community is just great. So anyway, enough preaching. So let's see. Anything else? Any questions? Nope. So I reckon we'll say good night. Till next time. See y'all.